Hi everyone, how are you doing? I'm Helal and this is Ty. In this video, we're going to speak about programming AVR microcontrollers and how to create your AVR dev board. And at the end of this video, we're going to test my own dev board. So let's get started. But before we get started, don't forget, I'm Helal and this is Ty. You get to listen to me and be all ears, and let's raise that curtain. We have two most popular methods of programming AVR microcontrollers. First, we have UART, and second, we have SPI. I'm going to speak a little bit about UART. We have a USB connector to connect it to our PC, and then FTDI chip to convert from USB to TTL. And we are going to connect our microcontroller to our FTDI chip by two wires, TX and RX. But you must put a bootloader on your microcontroller. Its size about 512 bytes. And when you power on your microcontroller is low booted because of the presence of the bootloader. And on the other hand, we have SPI protocol, USB to our programmer, like USB ASB, and we are connect our microcontroller by four wires, MISO, which it stands for master input step output, and serial clock, reset pin, and master output step input. The feature of this method, you don't have a bootloader section, so you will make use of the whole memory of your microcontroller. The whole memory is called the application section. And when you power your microcontroller is fast booted because we didn't have a bootloader, so our microcontroller is fast booted. And this is my own dev board. First of all, we have a socket, IDC 10 pin. This socket, we are gonna programming our microcontroller via this socket. So the programmer will connect this socket, and this socket will connect our microcontroller to program it. And here is the pin out, VCC, ground, and MOSI, ground, reset, serial clock, MISO. And the pins of the microcontroller is brought out pin headers, port A, port B, and port D, and port C. We have a crystal oscillator. You can put up to 20 megahertz of the crystal oscillator, but I prefer to use 16 megahertz and these capacitors to get rid of the noise. And here we have two pin headers to control our analog pins, analog reference, and analog VCC. So you may ask, where is the power of your microcontroller? You can power it by pure 5 volt by this terminal block. And if you don't have a pure 5 volt, you have 6 volt, 7, 8, 12 volt. You can connect your adapter via this terminal block. And this terminal block is connected to voltage regulator to regulate the voltage from 12 volt to 5.0 volt. And we have two capacitor at the input and capacitor at the output to smooth the output voltage. And here we have two pin headers, 5 volt and ground, to can power our sensors, or if you are using a 7 segment and you are gonna power this 7 segment, you will use this socket, 5 volt and ground, to power any sensor that you are using. And we have a LED. This is the LED is indication of the power, 5 volt, resistance, and LED. This is the indication of the power on the microcontroller. And we have another LED that's connected to PD5. Where PD5? Yeah. Here. PD5 to this resistor, and this LED. This is a built-in LED to can test your code, make sure all things are okay. Yeah, and here, this is the reset push button. I've used a reset push button and resistor. Its value 4.7 kilo ohm to make our reset pin on the microcontroller as input pull-up, high pull-up. This is the 5 volt. So if you didn't press the reset push button, so the reset pin of the microcontroller is high, so no reset. And when you press the reset push button, hello is passed through this push button to the microcontroller to can reset it.